Good evening. I'm Spot On Weather meteorologist Matthew Euler. Welcome to one of my favorite videos of the year. It's that time again. It's that time to issue the 2023-24 winter forecast. And I'm going to go through some reasoning. I may have to switch back and forth to draw some stuff out here on tonight's slides, on this video presentation slides. But this is the official Spot On Weather 23-24 winter forecast. So the first thing we're going to start off with in tonight's video presentation are the weighted winter factors. Like, what did I really look at closely in developing this year's winter forecast? There's a lot of the same characters that we look at most years. Some of these teleconnections or drivers such as the NAO, the QBO. Always want to take a look at that from year to year each winter. The PDO as well is one of those characters that we typically see that factors into the overall overlying atmosphere and the long wave pattern where the jet stream sets up, for example. And in this year, we have something different, though, a new character, and that is the El Nino. Now, we've sat with three previous winters have been La Nina. So things in the atmosphere are going to set up differently this winter, and we're going to take a look at the following winter factors. And you see the blue coloring of the font. That generally indicates the most significantly weighted factors that I'm looking at in determining this year's winter forecast. So we're going to start off with the first major significantly weighted factor, and that's the El Nino strength, as well as the multivariate ENSO index, MVEI, those considerations, and I'll explain what each of these means here as we go through the presentation. The second factor I looked at was the location of the warmest sea surface temperature anomalies, whether they're in the eastern central, or rather the eastern equatorial Pacific off the coast of South America, or whether the warmest sea surface temperature anomalies associated with the El Nino are in the central equatorial Pacific. Additionally, I took a look at the sea surface temperature anomalies in the North Atlantic, and that is represented by something known as the Atlantic multidecadal oscillation. The next significantly weighted factor here in blue is the easterly quasi-biennial oscillation we're expecting, the QBO, the easterly phase, as well as the North Atlantic oscillation, the NAO. Now this NAO, in my opinion, is going to have the biggest overall effect for this winter, or it's going to be the biggest overall factor this winter, and I'll explain more as we go through this winter forecast. And there again is the Pacific Decadal Oscillation, otherwise known as PDO. Again, so when we take a look at all these, I factored all these into my forecast, but the ones that are in that blue font, again, those are what I'm weighting most significantly in this year's forecast overall. Let's start now by taking a look. We're just going to kind of go down the line based on these bullets at these various factors for the winter season. We're going to start off with the El Nino strength. Now, what do we look at when we look for El Nino strength? We look at first to see what the sea surface temperature anomalies are like, or what those water temperature anomalies are like. For an El Nino, we look at the Nino 3.4 region in the equatorial east central Pacific, and we look to see what the temperatures, how those water temperatures are in relation to climatology. Are they running above normal for the water temperatures? Are they running below normal? Here is a look from the NMME. This was issued in September, and I wanted to show you just some different models represented by these different colored lines. The dashed line, by the way, is generally the mean or average of all these various models. And on the scale, just to get you acquainted with it, the zero line represents basically where those sea surface temperatures or those water temperatures should be in the Nino 3.4 region. The dash line is this dash line here represents positive 0.5 C. This dash line below the zero line represents the minus 0.5 C temperature anomaly line. And so anytime we have conditions ranging at, let's say these lines or these current conditions were within the positive 0.5 and the negative 0.5 Celsius temperature anomaly lines, if they were between these two dashed lines, we would have what's known as ENSO neutral conditions. But we don't have that this winter coming up. We have an El Nino. And there's a 95% chance that we're going to see El Nino-like conditions for the winter season for the United States. The black solid line here represents kind of like how the sea surface temperature anomalies have progressed since April. This is where we were situated back in the August time frame. And then again, this is the model output, the forecasting. Now you'll notice the green line here represents the GFDL SPEAR model. It is the most robust in putting the water temperature anomalies up closer to 2 degrees Celsius above normal in that Nino 3.4 region as we head into January. And we also see weaker models as well, like the GEM 5 NEMO, generally located further down, closer to, let's see how we divide this up, generally around 1.3 degrees Celsius is where it peaks out at. So the ensemble mean or average kind of splits the difference down the middle, and that is running generally around 1.5 to 1.6 Celsius. And I want to show you additional stuff over here on the right, just additional model type stuff and how things have changed over time. But overall, for the Nino strength, for the El Nino strength, you kind of see the range of where the models are projecting for the peak of those warmer than normal sea surface temperatures in that Nino 3.4 region. If we look at the CFS V2, now this is from today, and this is something that you can look at on a daily basis, the CFS V2 forecast for the sea surface temperature anomalies in that Nino 3.4 region. The dash line, again, this black dash line here represents the ensemble mean, or the average. It's the average of all the different model runs here, the model members rather. And so what is CFS V2 forecasting as of the 2nd of October 2023 today? It's not as robust. If you notice where this peaks out at, generally about 1.6 C here. The previous slide here we had, again, the GFDL SPEAR was much warmer, up to around 2 C. But we're starting to see more of all these lines here represent the different model or the forecast members. And you're starting to see more of a leveling off of this El Nino. In other words, I just don't think it's going to be as intense as what the models were projecting, say 2 to 3 months ago, or even back into June timeframe. Everybody was just blasting social media posts going, my gosh, this upcoming winter is going to have an El Nino that's going to run between 2 and 2.5 degrees Celsius above normal in that Nino 3.4 region for those water temps. Oh my goodness. Well, guess what's happening? It's kind of leveling off, and it's actually proving to be slightly weaker than projected. And that's going to have an impact on our winter weather. Now, look at this, and this is kind of the summation here at the bottom after I analyze these graphic here. But the CFS V2 forecast, again, is not as robust. A peak sea surface temperature anomaly about 1.5 to 1.6 degrees Celsius above normal. And that's falling off to the moderate territory into January and February. Look at the horizontal axis here. Look where this black average dashed ensemble line here, the ensemble mean, look how it's starting to go back downward now, right? The El Nino is weakening. Specifically, here you see into between January and February, definitely February, we're starting to see a drop off of the El Nino into moderate territory. Okay. Now, it's not just about the ocean effects that creates El Nino. It's not just looking at those sea surface temperature anomalies and trying to get the best model to forecast those anomalies in the Nino 3.4 region. We also have to look at how is the atmosphere responding. In other words, okay, we have all this warming of the ocean water, generally in the eastern and the central equatorial Pacific areas during El Nino years. But how is the atmosphere, the overlying atmosphere, responding to that warming of the sea surface temperatures? How is that changing over time? Right, so this is what it looks like for a typical El Nino pressure pattern. So you have lower pressure, generally in the eastern equatorial Pacific, and we see higher than normal pressure across the western equatorial Pacific. And generally air is going to flow or blow, basically the winds, The air is going to flow, the winds are going to blow from higher toward lower pressure. That's why we show you these arrows coming in from the west here, pointing from west to east, from the high towards the low pressure system. So we have an opposite pattern of what we should have going on. We should typically have cooler than normal waters located here over the eastern equatorial Pacific, specifically off the coast of Peru. And they rely on these cooler than normal waters, this upwelling effect to occur, where you get cooler waters from below the ocean surface to rise towards the top. And that's very important for the fishing industries off this coast, anchovies, some of the major fishing industries when you get cooler upwelling waters here. And that's normally what you see. And above that cooler than normal water, generally in this area, you get higher pressure. But instead, we now have warming waters during El Nino and low pressure instead. We have higher pressure where low pressure typically is located, with warmer waters typically out here in the western equatorial Pacific, and it's not during El Nino. Okay. Now, what's so important about where these pressure systems are located? Again, air is flowing from the high toward the low pressure. Normally we have trade winds in the northern hemisphere here blowing from the east toward the west. So the overall trade winds tend to weaken during El Ninos. In addition, we're just seeing again, that pressure gradient, or the wind blowing from the high towards the low pressure. And above these, when associated with this low pressure, we have rising vertical air motion. Associated with high pressure, we have sinking vertical air motion. So rising air motion associated with this low pressure over the warmer than normal waters, that's going to result in increased cloudiness and precipitation here. The high pressure associated with downward sinking air motion is going to be associated with drier than normal conditions across Indonesia. So this is just one piece of the puzzle here, or the sea surface temperature anomalies here we looked at first in determining the strength of El Nino. That's just one piece of the puzzle. We got to have the overlying atmosphere coupled to the water surface, those water temperature anomalies, to really realize the full potential of El Nino. Look at what I put down here. We have both atmosphere and ocean response to El Nino. The first thing we look at is we have anomalously warm sea surface temperatures across east central equatorial Pacific. We have that right now, so we meet that check mark, right? We have anomalously high sea level pressure over Indonesia. That's that high pressure I was mentioning here. And then the western tropical Pacific here. And we have lower than normal sea level pressure over the eastern tropical Pacific at this location during El Nino. 3, we get a reduction or reversal of those easterly trade winds. And when we get this situation where we get, anomalously high pressure over Indonesia, the western equatorial Pacific, and anomalously low pressure over the eastern equatorial Pacific, that's when we get that reversal of the trade winds sometimes, or just a general weakening of those trade winds. Additionally, we see suppressed tropical convection or rising air motion, thunderstorm development. We get a positive outgoing long wave radiation, that's what OLR stands for, over Indonesia here and the western Pacific in general. We get reduced thunderstorm activity out there, and we get enhanced convection. Or if you were to look at the chart that's produced by the Climate Prediction Center, it has negative values on the outgoing long wave radiation product, and that is associated with enhanced convection over the central Pacific, typically over in the vicinity of the date line. All right. Additionally, how do we describe this pressure difference between, let's say, Darwin, Australia, and Tahiti? We look at what's known as a Southern Oscillation Index. This is going to measure the changes between those two locations, Darwin, Australia to Tahiti, and that's going to give us a certain value when we measure those changes of sea level pressure across the Pacific. The SOI index, Southern Oscillation Index, has actually increased recently. I wanted to show you the recent red line here, just showing you, okay, so we saw this little bit of a decrease in the negative values here back in early September. Then we saw a crash of the SOI right on into late September. So see how this red line's kind of dipped down? But now look what's happened recently. In the last 2 weeks, we're seeing another increase or less negative values here on the 2nd of October. And so what that generally indicates is we have less of a pressure difference or a decreasing sea level pressure difference between Darwin and Tahiti, between these two pressure systems. We have less of a pressure difference, okay? What does that mean? When we have lower pressure difference between highs and low pressures, that means generally we have weaker winds, right? By the way, a negative value below -8, that generally indicates an El Nino. If we were to look at La Nina, like we've had the last 3 winters, that would be a positive value above +8 would be a La Nina. But we're looking and focusing this winter on the El Nino. So we're looking at negative values below -8 indicate an El Nino, and we're easily there right now. We're sitting at about -13 on today's date, 2 October. Another real interesting way we can see how the atmosphere is responding to the underlying sea surface temperature anomalies during El Nino is something that's known as a multivariate ENSO index in its version 2. So this is the MVEI. This is the atmospheric response, and I want you to just pay attention to some things here. This is an excellent chart here. This shows the evolution of the current El Nino event, okay, based on historical context. When we look back at previous El Nino years, all right, so we threw in the years 1983, 87, 1992, 1998, and 2016. Look at this dark gray line. This is showing you what the MEI V2, what that value is right now. Well, this was actually a little bit earlier in, not exactly right now because we're over here in October now. But this just kind of shows you how this has changed over time, this MVEI value, and notice what it's comparable to. It's comparable to 1992, this blue line right here. You see this? It's increasing at about the same level as the 1992 El Nino, okay? We had really strong El Ninos in 83. That's this dark line. See where the MVEI value was? Way up here, near a +2 by this point back in 1983. Now that was one of the super El Ninos. Also 97, 98, that was another super El Nino. And then 2016 was also, 2015, 16 was a super El Nino. Bottom line here is the atmosphere is behaving similar to not a strong El Nino, but a weaker El Nino. So it basically, the atmosphere is responding or performing below the level of what we'd expect for a strong El Nino. It's not even close to the Super Nino of 2015-16 winter at this point in time. As of today, the 2nd of October 2023, we do see positive values which occur during El Nino episodes. When we look at the MVEI, the multivariate ENSO index, we would expect positive values. Now look at this dark line here, by the way. This is 1983. It's way up here, isn't it? 1998 is not that much further below on the positive side, indicating the atmosphere is responding very strongly to the underlying warm sea surface temperature anomalies in that eastern equatorial Pacific area, okay? And then here's my main question for you at home. If the atmosphere does not behave like a strong El Nino, we're seeing that right now here in 2023, we will not expect strong El Nino-like conditions to develop. You got to have the coupling between that underlying above normal sea surface temperature anomalies in the eastern equatorial Pacific and the atmosphere, overlying atmosphere. If you don't get it, all bets are off for strong El Nino-like conditions for the upcoming winter. Here is another consideration to take into effect. This is my second bullet for the winter factors in my forecast. A central Pacific-based versus East Pacific-based El Nino events. I want you really to pay attention to how this Walker circulation changes. Where do the areas of rising air occur, or rising moist air? Where does this occur? Where does the descending air motion occur? Why is this important? This is one major circulation cell, and it's not just in the horizontal at the surface where we live. It also extends into greater vertical depths of the atmosphere. When we get a central Pacific-based El Nino, where we have the warmer than normal sea surface temperature anomalies over the central equatorial Pacific instead of the eastern Pacific, we get two distinct Walker circulations that set up. Anytime you have rising air motion here over the central Pacific near the 180-degree international dateline, look at this. You get a lot more clouds and a lot more rainy conditions, a lot more precipitation. And in the upper levels, the atmosphere, The cell, you get diverging air or upper level divergence above this rising air motion. And then you get sinking or descending air over the eastern equatorial Pacific as well as the western equatorial Pacific. And when you have descending air, it tends to dry out. You have drier than normal conditions in both these locations. That's a central based El Nino. An eastern Pacific based El Nino, look what happens now. This is when you have the warmest the normal sea surface temperature anomalies off the coast of South America. Now you got rising vertical air motion above normal precipitation over that eastern equatorial Pacific area. Look at the absence of rising air motion near the international dateline, 180-degree west longitude. You don't see it in this one. You just see one main Walker circulation, and it's weakened. You still see the descending drier air there in the western equatorial Pacific, whether it's east or a central based El Nino, but you see more of rising air motion. Now this is going to impact the overall downstream atmospheric effects for the United States weather in the winter season, right? And that's why we look at it. Additionally, you notice there's some westerlies here associated with the Eastern Pacific El Nino. All right, so bottom line here, I kind of describe it at the bottom. The central based Pacific El Nino events favors colder temperatures in the eastern U.S. You get the rising air motion, you get this vertical rising air. This particular rising cell over this location has major implications downstream into the eastern U.S., and the U.S. in general. Eastern Pacific-based El Nino events, meanwhile, they favor milder temps in the eastern U.S. during the winter season. All right, so in general, central-based El Ninos favor what's known as a positive Pacific North American pattern, positive PNA. That sets up and pumps up the heights in the western U.S. up to western Canada. And that generally tends to favor a colder winter season for the eastern U.S. Now, what we're expecting this upcoming winter, I'm going to show you. Here are the sea surface temperature anomaly forecasts. This is from the NMME forecast output back in early September. I'm waiting for the new data to come in. I have December, January, and February on the left. I have January, February, and March on the right. Anytime you see this orange color, the red coloring, the brown coloring, that indicates above normal sea surface temperatures. Whenever you see the blue shading, which isn't a lot on these particular graphics, when you see blue, that means below normal sea surface temperature. Okay, so what are we looking at for the months of December, January, February, according to the NMME forecast output? In December, January, February, we're still expecting that this brown shading represents, according to this model, the sea surface temperature anomalies at 2 degrees Celsius in this brown shading. And it's generally extending between the eastern equatorial Pacific and the central equatorial Pacific, kind of in between those two zones. If we look at the graphic here on the right for the forecast for January, February, and March, we're starting to see a little bit of a weakening of the El Nino conditions, but it's generally the same location there between the eastern equatorial Pacific and the central equatorial Pacific, okay? Still about 2 degrees C, but it is starting to weaken at this point in the months of January, February, March. So bottom line here, what we're thinking is El Nino will peak in December before weakening going from strong El Nino to moderate El Nino territory in January and February. Okay. Now, another factor that's very important, and it's been studied extensively, is this little area. Look at this graphic on the left. It's this area south of Greenland. The sea surface temperature anomalies, they're south of Greenland in the North Atlantic. This is the legend here in degrees Celsius. By the way, I pulled this from the Journal of Climate, particular issue 28.4. Whenever you see above normal sea surface temperatures south of Greenland across the North Atlantic, that's indicative of a positive phase of what's known as the Atlantic Multidecadal Oscillation, the AMO. This was a graphic I pulled back on 25th of September last week. Notice where we have above normal sea surface temperatures, generally in the same location that's indicated here on the left. So this is where I put the circle. This is where we have above normal sea surface temperature anomalies in that spot. So the AMO, the big thing with the AMO, it can drive the NAO, the North Atlantic Oscillation phase. Whenever you get above normal water temperatures south of Greenland across the North Atlantic, That's a positive AMO, and that will generally equate to a negative North Atlantic Oscillation or negative NAO regime for the winter. So we'll have to keep an eye on this as things progress. But right now, I tend to look at this location, and if I'm looking at this location right now with a positive AMO, I'm thinking of a negative North Atlantic Oscillation setting up at some point during the winter. Here is the general monthly values for the AMO index from 1856 to 2022. And you'll notice the AMO tends to go back and forth between warmer phases that you saw here from 1860, generally right up to, 1890. We see colder, negative AMO phases, below normal water temperatures. They're south of Greenland and the North Atlantic from the early 1900s to about the 1930 time period. And then we saw warming again of that water south of Greenland across the North Atlantic. That's a positive AMO. And then another negative AMO. Look how strongly negative the AMO actually went in the late 1970s when we saw a lot of cold winter time action. That basically tells me that the winters were dominated really by a positive Pacific North American pattern ridging out over the western portions of North America when I see this kind of negative drop to the AMO. And then now we've kind of, from the year 2000 to present, we're kind of sitting around in a positive AMO once again. Okay. Another factor that, this is one of my more significantly weighted factors, is this quasi-biennial oscillation, the QBO. Okay. We are expecting an easterly descending QBO this upcoming winter. What does that do for our weather, specifically in the mid-Atlantic, even in the eastern U.S.? It tends to promote colder than normal temps across the eastern U.S. Think about the QBO. It's basically the winds in the stratosphere over the equator, and they alternate between a westerly phase and an easterly phase. Westerly phase corresponding to westerly winds in the stratosphere over the equator, and easterly QBO is equating to easterly winds in the stratosphere over the equator. We're heading to an easterly descending QBO phase this winter. Now, they also tend to favor a weakening of the stratospheric polar vortex. So that's an important factor to take into account as far as temperatures across the eastern U.S. for the winter season. This is today's Singapore radiosonde observation, the RAOB, showing the zonal wind in meters per second. And it generally shows a negative phase in the upper levels of the stratosphere over the equator right now, or an easterly phase. Okay, so you kind of see what's going on here. This here, switching gears now to the North Atlantic oscillation, this NAO is, to me, the number one factor for how this winter is going to turn out. We have two roads we could go down with this, okay? If we get the negative NAO along with El Nino, which we have a 95% chance for El Nino. NAO is a little bit trickier to forecast. It's not very easy beyond 2 weeks to come up with the phase of NAO. This is what makes winter weather forecasting so difficult, is trying to figure out this teleconnection, the NAO, and what phase is it going to favor. We look at long-range models to see if there's that signature of blocking up across the North Atlantic or the North Pacific side. But in general, this is difficult to forecast for. Just kind of showing you these scenarios, though, if we get the negative NAO along with El Nino, the winter is going to be colder and snowier than normal across the mid-Atlantic. If, on the other hand, we get a positive NAO along with an El Nino, the winter is going to be milder and less snowy than normal across the mid-Atlantic. This graphic shows you the various phases of the NAO and how they've changed over time. We're going back to that crazy NAO back in 2010. It reached record levels back in that 2009-2010 winter season. Lasting negative all the way to 2011, for goodness sake. And then, we see these red peaks here in the positive territory, indicative of a positive NAO. We saw quite a positive NAO from 2018 through early 2019 over this period. Then we saw another drop off the NAO in 2019, and then we saw another drop. We're seeing another drop off the NAO right now, presently. We've seen quite a winter with a negative NAO right now. The Pacific Decadal Oscillation, another factor we definitely need to take into account. This is showing the history of the PDO, or Pacific Decadal Oscillation, showing various phases. You'll notice that the 1960s and 1970s were generally dominated by a negative PDO. One thing of note here when we talk about negative PDOs, that 2009-2010 winter season, which was a really significant winter across the eastern U.S., featured a negative PDO. I look at social media posts and folks are comparing, hey, it's a negative PDO winter. That means that the trough's going to set up over the western U.S. and the east is just going to be warm all winter long. But this right here proves that other teleconnections can overpower the negative side of the PDO, because that winter of 2009-2010 was a very significant winter, specifically across the mid-Atlantic up to New England. And it was a negative PDO winter, folks. Okay, so just because one teleconnection favors something doesn't necessarily mean the winter is going to turn out that way. Look how strongly negative the PDO got. Generally, it was pretty significantly negative here last winter, early 22-23 winter. It really dropped negative pretty significantly. But for this upcoming winter, we're expecting to be in a negative PDO phase. That would generally promote upper trough over the western U.S. and cooler and unsettled weather across the west, and that downstream ridge, warmer and drier over the eastern U.S. So again, I'm just stating the facts of what these, whether we're a negative or positive PDO phase represent. If you look at the positive PDO phases were really prevalent, where we saw those occurring in the 1980s and pretty much the 1990s. A lot of positive PDO phases going on in those particular 2 decades. What does the PDO and PNA, what happens between these two teleconnections, okay? First things first, the PDO has a high correlation to what happens with the Pacific North American pattern, that PNA pattern. A positive phase of the PDO, where we get warmer than normal water temperatures off the west coast of the United States, that generally tends to correspond to a positive PNA pattern. We get this upper level ridge that generally tends to park itself across the west or western North America, even up into western Canada, and we get an upper trough over the eastern North America. Okay, a negative phase of the PDO, on the other hand, where we have colder than normal water temperatures off the west coast of the United States, that corresponds to the opposite effect, where we get a negative PNA pattern with troughing over the western portion of North America and an upper ridge over the eastern North America. So let's continue on. Different research has been conducted, and I quoted the researchers here and the year they published this, but we have seen decadal variability of winter cold extremes over eastern North America, and these two authors discovered that it was mainly due to the Pacific Decadal Oscillation. A positive PDO promotes cold extremes in the lower latitudes of eastern North America due to the presence of that positive PNA pattern. And then the PNA is a prominent mode. When you see a PNA, it's a prominent mode of planetary scale atmospheric variability over the North Pacific Basin in winter, and is closely related to the strength of the Aleutian low end of the PDO. This was conducted by Lattif and Barnett, this research back in 1996. So the bottom line here is El Nino. El Nino generally tends to favor stronger Aleutian low pressure systems in the Gulf of Alaska. That will generally tend to weaken, in my opinion, it's going to weaken the effects of the negative PDO, because you're going to have strong southerly winds blowing up along the west coast of the United States, as well as into Canada, off the west coast of Canada. And you're causing your heights to rise. There's a coupling between the basically the overlying atmosphere and the ocean surface. And so I'm really keeping an eye on that for this winter. Here are some graphics that kind of explain things a little bit better. When we have a positive PDO, this is showing you the blue circular areas indicates lower than normal heights associated with troughs. The orange coloring indicate abnormally higher than normal heights, upper level heights, indicating ridges. And so with a positive PDO, you generally get these warmer sea surface temperature anomalies off the west coast of North America in general. And as a result, you get more of an upper level ridge parked in this location over that warmer body of water, so to speak. So you get upper level ridging into the western US, western Canada, and it's associated with a positive PNA. And then you get downstream troughing, more unsettled, more stormy across the eastern US when we have a positive PDO resulting in this jet stream configuration, the shallow line here, of a ridge in the west, trough in the east. On the other hand, if we get that negative phase of the PDO, it generally tends to favor the negative phase of the PNA, where we get that jet stream to dip down across the western U.S., and you get colder than normal sea surface temperature anomalies off the coast of the Gulf of Alaska, off the coast of Canada, off the west coast of the northwestern United States. And so the jet stream takes on more of a trough configuration, much more stormier across the western U.S. and colder than normal. And then you get downstream of that upper level ridging across the southeast and mid-Atlantic, where it's warmer and drier than normal because the jet stream is way up to the north. And so beneath the south side of that jet stream, you got warmer conditions in the winter. So there's a big difference in how the positive PDO with warmer than normal sea surface temperature anomalies set up versus the negative PDO with colder than normal sea surface temperature anomalies, and how it plays into the coupling effect between the ocean and the overlying atmosphere. And this is the association with the jet stream, storm track, the long wave pattern, and that impacts temperatures and precipitation anomalies during the winter season. All right, so we're kind of talking about many different factors here. We are expecting a negative phase of the PDO this upcoming winter. Again, that would promote more of this type of scenario, but we have other things that we have to take a look at. We can't just look at the negative PDO and say, hey, it's a slam dunk. This is the pattern for the winter. When I take into account, again, that PDO, the Pacific Decadal Oscillation, the El Nino Southern Oscillation, overall during ENSO events, we see tropical Pacific sea surface temperatures induce tropical precipitation shifts. This forces these Pacific North American, the PNA wave trains. That was a research conducted by Trenberth et al. In 1998. And this results in altering air temperature, wind, humidity, and clouds across the North Pacific. Now, during El Nino, this is the key to me. And of course, this is going to be based on the strength of the El Nino. The stronger the El Nino, the greater the impact. The weaker the El Nino, the lesser the impact. But during El Nino in general, we see the Aleutian low pressure system typically stronger than average during winter. This generally tends to favor a positive PDO pattern, or at least a weaker negative PDO pattern, due to stronger southerly winds along the U.S. West Coast. Again, depending on the El Nino strength, how the atmosphere responds. During La Nina, which we had the last 3 winters, the Aleutian low pressure system is weaker than average during winter. And that generally tends to favor a negative PDO pattern. Weaker southerly winds, a weaker pressure gradient along the U.S. West Coast. And then this one, I've shown this one in a previous video I did when you talk about PDO. When El Nino peaks during winter, the North Pacific center of the PNA deepens, resulting in a positive PDO phase. And this is why you get variations in the evaporation rates, the wind stress, and air temperatures in the North Pacific. Here's a nice breakdown for you. We get a negative PDO that's generally associated with weaker El Ninos. Or you can get a negative PDO with stronger La Ninas, okay? So there's 2 ways we get a negative PDO generally in the winter season. Cooler than normal water temperatures off the U.S. West Coast and off the west coast of Canada. We get either a weaker El Nino or a stronger La Nina. We're not expecting either of these this upcoming winter season. Positive PDO is generally associated with a stronger, longer-lasting El Nino, as well as a weaker La Nina. When the La Nina is fairly weak, you still get a positive PDO. Okay, so just wanted to really summarize, what the PDO phases are associated with, whether we're talking weak El Ninos, strong La Ninas, strong El Ninos, or weak La Ninas. There you go. All right, so before I show you my graphics for what I'm expecting this upcoming winter, my number one analog winner, my last video I produced was on El Nino analog winners. I am going to go with the 2009-2010 winter season for my number one analog this winter. Now, when I say that, I'm not saying this winter is going to necessarily be as bad as the winter of 2009-2010, but I will point out some similarities between this upcoming winter forecast and the 2009-2010 winter season. First thing first, we had an easterly QBO, plus we had, if this comes to fruition, now we're sitting in early October, and I realize this, okay? we definitely are expecting the easterly descending phase of the QBO. Right now, my gut right now, I feel as if we're going to have a similar strength El Nino to 2009-2010. And I think we're going to peak out at 1.5 to 1.6 degrees Celsius sea surface temperature anomaly in the Nino 3.4 region. It may be slightly higher. I might be underdoing this slightly. Perhaps we get up to 1.7 C above normal. I do not see a super El Nino. I don't see it. I don't see in excess of 2 degrees Celsius. I don't see the 2015-16 winter here. I just don't see it. Another similarity that we're forecasting for this winter versus the 2009-2010 winter, the negative PDO. It existed in the 2009-2010 winter. It's forecast to exist this winter. Additionally, the 2009-2010 winter season had a development of a negative NAO. Now, that particular winter had record level low or negative values for the NAO. 2009-10 winter season. Am I expecting that kind of amplitude of a negative NAO? Too early to tell. But I am expecting that negative NAO to come in and be a player for this upcoming winter season. Duration to be determined. Magnitude to be determined. There is one significant difference, though, that I want to point out, and that includes a potential east-based El Nino this winter. It's looking that way. I showed you it. I showed you the forecast from the NMME right here. This brown coloring indicating the greatest sea surface temperature anomalies, the warmest areas of sea surface temperature anomalies, is generally closer to the eastern equatorial Pacific than the dateline out here. Okay? So I am expecting more of an eastern-based El Nino. And that is a major difference because in the 2009-2010 winter season, we had a central-based El Nino. Okay? This could be one of those wild cards. I'm going to be honest. East-based El Nino events tend to have milder temperatures in the eastern U.S., including the Mid-Atlantic. I'm not gonna sugarcoat this, but I just feel like the other extratropical forces are going to become more dominant than where this sea surface temperature anomaly situation is set up. So, what am I thinking here? Some more of my final thoughts here. Now, I'm focusing this particular on the Mid-Atlantic. But you will see my overall U.S. forecast here in a moment with my graphics. I'm expecting a strong El Nino in December, and I think it's going to peak out in December. And again, I'm thinking anywhere from 1.5 to 1.6 degrees Celsius above normal sea surface temperatures in that Nino 3.4 region. Now, again, maybe I'm underdoing this a little bit, okay? But I just don't see 2C above normal out there. I think that strong El Nino in December is going to transition to a moderate El Nino in January and February. What does that mean for us in the Mid-Atlantic? Cooler and wetter weather. We're going to see more of a suppressed southern storm track. This could result in some big storm systems, generally from the southeast to the Mid-Atlantic coasts in the months of January and February. And now, I'm not saying all the storm tracks are going to just magically stop off the coast of the Mid-Atlantic. Some of them could go all the way up to New England, but generally when you talk about El Nino winters, the greatest precipitation anomalies on the above normal side generally tend to exist from the Mid-Atlantic to the southeast, down to Florida. We are going to be seeing that negative easterly QBO. That, along with a strong El Nino initially, it's going to increase the probability. Notice I say increase the probability, not a guarantee, but to increase the probability for a sudden stratospheric warming event, which is going to result in warming temperatures in that polar stratosphere. And I'm thinking that's going to occur in January. And then we'll see below normal temps across the eastern U.S. in later winter, late January and February after that sudden stratospheric warming event in the weakened stratospheric polar vortex. We will see that negative PDO again this winter. Again, just a reminder, it did occur in that colder than normal winter in 2009-2010. This negative PDO, by the way, is not the only game in town, and that's what I'm really emphasizing here. Additionally, in 2009-2010 winter season, We did see a minor sudden stratospheric warming event, which occurred in early December, but then the major sudden stratospheric warming event occurred in late January. By the way, I'm just showing you this graphic here. This is not from 2009, 2010, but I thought it was a good graphic to show generally what kind of upper level pattern you'd want to get colder than normal temps with this trough here into the mid-Atlantic and the eastern U.S. Notice we have a positive P and A pattern here by the orange coloring and the brown. That's anomalously above normal heights associated with upper level ridge. And then we also have a negative NAO in the Greenland on this particular graphic. And in between those two upper level high height centers, we have this troughing and a pathway for colder Arctic air to come down towards the eastern U.S. So this is kind of like one of those nice patterns you'd like to see in the winter season, along with a southern storm track here too. Okay, so here's my winter forecast. I'm expecting a mild, this is for the mid-Atlantic, I'm expecting a mild wet start to the winter in December, transitioning to colder and wet in January and February. There'll be that more suppressed southern storm track with a stronger subtropical jet stream that we typically see in El Nino winters. We'll see the combination of a negative NAO and El Nino. It's going to result in more significant winter weather during the late winter period, I believe. So January into February. Although we'll see east-based El Nino in place, I do believe the U.S. weather in the winter is going to be influenced more strongly by these factors. We're going to see a weaker stratospheric polar vortex. We'll see a negative NAO develop in the late winter, and we also have that negative QBO. All three of these generally tend to favor colder than normal temps for the eastern U.S., specifically the mid-Atlantic. The sudden stratospheric warming is going to produce a weakened stratospheric polar vortex in January. And then we'll see colder temps move into the area, the mid-Atlantic, late January and to February. The majority of the snow for the mid-Atlantic this upcoming winter, I'm expecting to fall it's going to fall in January and February with above normal snowfall amounts expected. Here are my maps, and I know they're very archaic. You probably get a laugh out of this. But in general, what I'm expecting for temperatures. I'm expecting above normal or warmer than normal temperatures across the Pacific Northwest. I'm expecting above normal, a warmer than normal winter across the northern plains from the Dakotas to Minnesota to Wisconsin and Michigan, eastward into parts of northern New England. Not all of New England, just northern New England. Specifically in Maine, Vermont, New Hampshire could see above normal or warmer than normal winter. And then down here to the south, because of El Nino as a primary influence, along with a negative NAO. Now, this is mainly due to El Nino, but we get a negative NAO. Obviously, the colder temperatures could be further to the north here. So we'll have to keep an eye on that in late winter. But in general, with the El Nino concept in mind, I'm expecting increased cloudiness and more precipitation in this general area, resulting in less sunshine and cooler than normal temperatures here. Okay, anywhere where you don't see anybody, any color, or you're not shaded in an area or enclosed with any circles, that indicates near normal or near average. So near average type temperatures across the Intermountain West, across the Missouri River Valley, Ohio River Valley, right over towards DC, near normal, New York City, near normal. For the precipitation forecast for the upcoming winter season, December, January, February, drier than normal conditions across the Pacific Northwest, drier than normal conditions expected across the upper Midwest, the Midwest in general, Ohio Valley, drier than normal, up to northern New England. And then wetter than normal conditions with that primary storm track, the increase of tropical jet stream from Southern California right over to southern Arizona, southern New Mexico, and then another area of above normal or wetter than normal conditions from Texas, southeastern Texas, working our way right along the Gulf Coast of Florida, up to the mid-Atlantic, up to you in DC. And then finally, the snowfall forecast map. Now, I did notice something after I created my outlook here on these graphics. Looking back at some further data after I created this, I'm actually, let me draw this out. I actually could see this wetter than normal area extending a little bit further here to the north. okay, where the red line is. I think that could be our northern edge of wetter than normal conditions. I think I went a little bit too far south with my initial assessment. And I'm comfortable with putting the above normal line of wetter than normal conditions where this red line exists up here to the north or the Tennessee Valley. Because if I go back here, I'm going to highlight that same area for above normal snowfall. I think what we have is the storm track is going to go across like this with increased strengths of tropical jet, kind of come down like this. And I think the main storm track is going to go off like this. Now, there may be some cases where you get blocking up here over the North Atlantic, and that's not going to allow these systems to move out to sea, okay? There may be some nor'easters that kind of go up the coast further before going out, okay? So, in general, I'm thinking that this is going to be your major storm track here from Southern California right across the Gulf Coast. It's definitely going to be wetter than normal here in Florida, and then this is your major storm track here. And this is why I mainly think, I do believe we could get some storms that go up off the New England coastline and out based on a negative NAO in this upper level ridging here. Higher than normal heights could do that, blocking these systems from escaping back out to the Atlantic. But I think primarily the storm track is going to be right off the mid-Atlantic coastline. So anybody to the northwest of this red arrow here, that's where I'm showing the above normal snow. Look where I'm putting my above normal snow. If I got a storm track like this, okay, right up here like this area where it's above normal snowfall is going to be on the colder side of the storm track. And so we get a polar jet that kind of comes down here from time to time for the winter, okay. We're going to get these colder chunks of air that are going to come down from Canada, and they're going to merge with this moisture that's going to ride up and over that colder air at the surface. And I think this is going to be your above normal snowfall area. I think it'll be below normal up here to the north because the El Nino generally favors that more suppressed southern storm track. I do think it'll be above normal also out here into the Sierra Nevadas of California, just by virtue of the fact that we have a lot of subtropical moisture coming into Southern California. And when that air is lifted to the higher elevations, it's going to fall as snow, and heavy snow. I do expect below normal snowfall across the Pacific Northwest, below normal snowfall across the upper Midwest into Maine and parts of southeastern Canada. All right, that wraps things up on my winter forecast. Again, there's so many variables involved when I look at this forecast. This is a very challenging forecast, okay? When we look at kind of like what I hit in the video, okay? We look at all these factors here, all right? These can change, especially, let me go back here. I tell you what, the NAO, this is my biggest factor for the winter, period. I've looked at the research. Whenever you combine a NAO, whether it be positive or negative, it's going to determine, that along with El Nino together, combined, is going to determine what goes on in the eastern U.S. and the mid-Atlantic for temperature regime. I'm telling you, if it's a positive NAO plus El Nino, it's going to be a milder than normal winter. It will be. But if it's a predominantly negative NAO plus El Nino, we're looking at a colder than normal winter for the mid-Atlantic. And with that southern storm track, you see where the wet is. I expect it to, again, get off to a milder, wetter, above normal start in December. And then when the El Nino starts decreasing in intensity down to moderate territory, I think it's going to be a favorable storm track right here for the winter season, right off the southeast and mid-Atlantic coast predominantly. Again, you could get some pretty good snowstorms up here in New England. But in general, El Nino winters from the mid-Atlantic southward, this is the sweet spot. Okay. All right, that wraps things up tonight in my video. I hope you enjoyed this presentation. I got some additional videos coming up, including my teleconnections discussion. I'll be kicking that off here shortly. We'll be looking at the weekly teleconnection outlook. And, I'm looking forward to just kind of watching how things unfold. We have the CANSIPS model that just came in for the winter outlook, waiting for the European CS5. See if they maintain their consistency in the outlook. That's the most important thing I'm looking for. And that wraps it up, everybody. Looking forward to producing some more great quality videos. Thanks for subscribing to this Spot on Weather YouTube channel. Until next time, everybody, take care and God bless everyone.